Hello, ladies and gentlemen, and welcome back. We're in the midst of Part C on the Grade 8 level Gauss paper from 2007. We're right in the middle. We're in question number 23. Hopefully you have given it a try. What does 23 have to say? There are various ways to make 207 using only $2 coins and $5 bills. One such way is using one $2 coin and 41 $5 bills. Including this way, how many different ways can $207 be made using only $2 coins and $5 bills? Okay, with a question like this, I like making a little chart, and that's what I think we should do. So we've already been told one way to do it. I'm going to count the number of coins that we use, the $2 coins, the number of $5 bills, and I'm also going to count their total, and the total should be $207. Okay, so they said one $2 coin and 41 $5 bills. If we had a calculator handy, we could easily check 41 times 5 is $205 plus one $2 coin is $207. Great. So, what can we do? Well, we could, for example, try and do it with less $2 coins. What if we had zero $2 coins? Could we do that? Well, everything would have to be $5 bills, wouldn't it? So the total we'd get, no matter what number we put here, 40, 43, anything, is going to be a multiple of 5, but we want the total to be $207. So that's never going to work out. Okay, new plan. What if we increased the number of $2 coins? Okay, what if we used 3 coins or 7 coins or something like that? What could we do there? Well, if we're increasing the number of $2 coins, but we want the total to stay exactly where it is, we're going to have to correspondingly decrease the number of $5 bills. If I just keep it with 41 $5 bills and I add in another $2 coin, suddenly our total is $209. Okay, that's not what we want. We want $207. Okay. So we increase the number of $2 coins, we have to decrease the number of $5 bills. That's fine. And then we want the same number. We want $207. So suppose I were to increase the number of $2 bills a little bit. What if I had 2 coins? Okay, two $2 coins. Well, for my total of 207, taking away 2 coins, two $2 coins, subtracts off $4, I'm left with 203. But that's not a multiple of 5, so there's nothing we can do here. That's not going to work. What if I had 3 $2 coins? Okay, so then we'll be left with a total of 201. That's close, but still not a multiple of 5. What if I had 4 $2 coins? So then it's 207 minus 4 times 2 is 8. It's 199. Again, you're not going to get $5 bills to have a total 207. What if I had 5 $2 coins? So now I'm doing 207 minus $10. Well, we'd have $197 left. We can only make that up with $5 bills. There's no way. It's just not a multiple of 5 over here. Okay. How about 6 coins? 6 coins, and if this doesn't work, I'm going to give up. Well, 207 minus $12, 6 times 2 is 12, leaves me with 195. And hey, that is a multiple of 5. In fact, it's 39 times 5. So 6 $2 coins, 39 $5 bills, we will still get a total of 207. So what's going on here? Why do I have to increase my $2 coins by this many? Okay. Well, when we add on, let's say P number of coins, when we add P $2 coins, what we're really doing is increasing the total amount in dollars by 2 P dollars. But we want the total to stay constant. So we have to subtract off a corresponding number, let's say Q. We have to subtract off Q many bills, Q many $5 bills, and we want that to have no change, so $0 and change. So that tells me 2 P dollars must be the same as 5 Q dollars. well, 2 isn't a multiple of 5, so 5 has to be a factor of p. Otherwise, because over here it's a multiple of 5, that means this must be a multiple of 5. P has to be a multiple of 5. Similarly, Q has to be a multiple of 2. And that's why we go from 1 coin to 6 coins. We have a difference of 5 coins here. And we go down by 2 $5 bills. Now, not everyone's going to see that pattern right away. I've been doing contests for a long time, and frankly, I've grown out of grade 8. Okay? So, you're not going to see that right away. You know, some of you might. Some of you, you've seen questions like this before, but not everyone's going to see it right away. So we would still keep plugging away at it, and eventually we'd start to get a pattern. We'd start to realize that, 2 and 3 and $4, 4 of the $2 coins aren't going to work, but 6 will. 6 and 39, that works. That gives me a total of 207. And as long as we start doing this in a methodical pattern, we don't just start guessing, ooh, will 17 $2 coins work? We don't just bounce around. We do this in a methodical way. We'll find 11 works, and corresponding with that will be 37. And that also has a total of $207. And you'll find that increase this by 5, you'll get 16 will work. And we can decrease this by 2 more, we'll get 35. And at any step, we can stop and check. 16 times $2, $32, plus 35 times 5 gives me $207. And we can keep going like this. 21, 26. Eventually, you'll notice the pattern that, the ones in the middle just don't work. I increase this by 5. Even if you don't understand the reason, even if you didn't follow my explanation, that's okay. 31... and then we'll be down to 29, and it's just going to keep going. Okay? When could this ever stop? Well, we can't have negative coins. We can't have negative bills. Now, I notice the $5 bills are decreasing. So eventually, since I'm going down by 2 each time, eventually I'm going to get down to 3, and then 1, and I can't have a negative $5 bill. I mean, sort of that counts as owing, but that's not actual bills in hand that we can work with. Okay? So with 1 there, you'll have 101 $2 coins. And before that will be 96 coins. We can even check that. 96 times 2 plus 3 times 5 is indeed 207. So these are all going to work out. So we recognize a pattern, and it might take you a little while. We recognize a pattern, go up by 5s here, go down by 2s here. We recognize where we're going to stop. $1 $5 bill, that's it. You can't go any lower. Now it's up to us to count. How many of these combinations are there? And if you list them all out, you count them up fairly quickly. But maybe you have a chart like this where you realize the pattern and you jump to the end and say, this is my ending condition. Now I ask how many in between. Well, there's lots of ways we can count it, but if I look at the $5 bill category, that column, I'll notice I have odd numbers. In fact, every odd number is represented from 1 to 41. So the number of combinations is just the number of odd numbers between 1 and 41. Okay, so how can I count those up? Well, the number of odd numbers from 1 to 40 is just going to be half of all these numbers. There's 40 numbers from 1 to 40. Half of them are even, half of them are odd, so that's 20. And then 1 more for our 41. So that should be 21 different ways. Okay, is 21 one of our answers? It absolutely is. It's down here, it's E. So we're going to say E. There are 21 different ways that I can make the total of $207. Okay? But this question just boiled down to pattern recognition. Okay? That's basically it. That was the bulk of it, is recognize the pattern in the chart. Then you ask, when must this pattern terminate? When does the word problem, making coins and bills total up to a certain amount, break down? When does it stop making sense? It's about the time that you get negative bills or negative coins. Okay? You'll notice I started first by going back and saying, what if I had less $2 coins? Okay? If they had, instead of giving me 1 and 41, they'd given me something like 26 and 31, 26 $2 coins and 31 $5 bills, I would have needed to check both ways. Less $2 coins and more $5 bills, and more $2 coins and less $5 bills. It would have the table would have filled out from the middle to the top and the bottom. Okay? So we ask ourselves, when does my chart end? And in both directions we would need to in general. Okay, so pattern recognition, realizing when the patterns are going to break down, and then it just became a question of counting. I chose to count the middle column, counting odd numbers. You could certainly count from 1 to 101 using things that are a multiple of 5 plus 1. I think that's a little messy, but we ultimately get our answer of E. Okay, so that does it for question number 23. I will see you guys for question 24 in the next video. Until then, take care.